We are going to start with the today questions of Leetcode. So let's understand the today questions. Today questions is 834 and we are going to do sum of distances in the tree. Okay, so there is an undirected graph, right? There is undirected graph with n nodes level from 0 to n minus 1 and n minus 1 edges. Okay, so you are given an integer n and the array edges where the edges of I is a of I and b of, and then we have to end, then it is saying that it is indicated an edge between a of I and b of I is the integer. So what we have to do, we have to return the answer of n, where answer of I is the sum of distance between the ith node to the tree of all the nodes, right? Let's assume this is the example we have given. So total node is what given, n is 6. If you count this, 1 2 3 4 5 6, total how many nodes we have given? N, right? N number of nodes we have given here. So if we calculate from edges, right, what edges is given? 0 to 1 it is given, 0 to 2 is given, 0 to 3 is given, 0 to 4 given, 0 to 5 given. Okay, but here you will see the edges, right? What we have given? Edges, right? Edges of 0 1 means from here to here. Then second is 0 2, and then what given? 2 3, 2 4, 2 5. Okay, like this we have given the edge. Now what we have to do, we have to return the sum of the given nodes, right? How will calculate that, right? So it is saying that if we are going to this, we have to return the answer, right? The length of answer is n, means answer size should be number of nodes. Okay, and then the answer of I is nothing but the sum of distance between ith node to all other nodes. Means if I'll start with 0 node, right? The first node, it means 0 to 1, that is 1, then 0 to 2, then we have to do sum, then from 0 to 3, 0 to 4, 0 to 5, and we have to calculate. As you can see here in the answer, right, in the explanation center, distance of 0 1, distance of 0 2, distance of 0 3, distance of 0 4, distance of 0 5, and from 0 to 1 it is 1, that's why 1. 0 to 2 its distance is 1, and it is taking distance 0 to 3 is this edge and this edge, 1 plus 1 it's 2 edge, right? And similarly for 4 and 5, 2 2, so it is coming 8, correct? So total we are getting 8 as a so index 0, right? Similarly we'll calculate for 12, we'll calculate for 6, 0 1 2 3 4 5, fifth index that will calculate all the value. Okay, let me take the pen. Now if we will talk about the answer, right, I have tried my own way. So first time I got the runtime error, it is saying time limit exceeds, so I have optimized this problem and I will try uh, the approach, right? So what we have to do, we have to take a answer and count, right? Answer is what? An array of size, right? That we will initialize here, right? Because answer should be the given node, answer should be the given node, correct? Next what we have to take, we have to take count, right? So we have to count. Why we will count? Because we have to see how many uh, node we have, right? We have how many childrens we have. Okay, you can say. Another we have graph, right? Graph is what? Graph is means we have to take a set, right? We have to take a list, you can say, right? A list of nodes, right? So set integer means whatever we will put here in the graph, the node should be always unique, there is no duplicate, right? And so that we will take a list of set of integers. So set means if we'll put in these multiple times, right, that the duplicate will not come, and that's the our node. Okay, so I think you understood here. We'll take one n, int n, that will take the size of the array, right? Size, sorry, number of nodes. Okay, so number of nodes we are initializing here, number of nodes we are initializing here, right? This dot n equal to n means we have the node, right? Now if we'll talk about, we are initializing now what? Graph, answer, count, and array field. Through the array field, what we are doing here, through the array field, we are actually doing initial value we are filling in the count. Okay, we are filling in the count. Count is what? Count is nothing but an array, right? So we'll fill all the value with 1, right? So in the calculation side, it will be our easy, right? Now from 0 to n, right? From 0 to n, we'll move all the nodes. We will move and we will initialize the it's what we can say, will all the node, right? We will initialize all the node, and because we have to define, see, if this is a node, right? So we have to add all its children. How many children it's have? So its children can be 1, 2, 3, like this, correct? So that we will take a set, so that this will be remain always unique. That's cannot become a duplicate. That's why we have taken graph.add, right? So for this node, for this, if this is the parent node, so all children are unique. So when we talk about this one, so its children will be unique, right? That's we have to take here. We have to initialize our node, right? And all the edges we will move and we will add the value there, right? So what we'll do here, we'll take edges, from the edges that we are passing here, from the edges we will take one by one edge, right? So if we'll talk about the first edge, right, this is what we'll do here, we'll take first edge and we'll check, right? So edge 0 means what? This we are talking about this one, right? We are talking about this one. So we will pass graph dot get edge of 0 if the graph have that edge, right? If that graph have the edge, right, there will be some value, right? If graph dot get will do, there will be some value, right, that will come, right? And then we will add at that value, we will add what? Is of 1. Okay, we are getting the graph, right? And when we will pass graph dot get is at 0, means we'll get this graph, and we can do, we will add its all children. It's is 1. What is 1? What we have? The this one we can say is this one. Another, if we'll talk about this one, then its children will come as of 0, or reverse you can say that. So we will have its all children 0 and 1. 0 and 1 means this is the children 1 and this is 0 as a children, as a parent, right? So we will have children node and child node, both will have here, correct? Another, what we have to do, we have to calculate DFS of what? 0. Give me 1 minute. Here we will do we have done already, right? Now we have to do DFS of what? 0 minus 1, DFS of 2, 0 minus 2. Okay, so 0 and minus 1 what? So current node value is, if we will taking 0, so parent is what we have? Minus 1, correct? Why we are doing this? Because we have to check all the nodes, right? How we will do that? So coming to here, we will get graph.get, right? And node, we will pass the node. So this is nothing but, if we talk about this the above graph, right, you can take this graph, right? So this graph dot get, right? So this graph dot get means, if we have some value here, right, we'll have a what? Set. We will have all the nodes here, correct? All the nodes. So what happened? We will move to one by one children. This graph X, and it have all its children C1, C2, C3, like that. Okay. So what will happen? All children, for this we are doing a loop. We are doing a loop. Okay. So if child not equal to parent, if child is this is not equal to this, right? This is not equal to this is not equal to this, or this is not equal to this, right? In this way, what we will do, we will move to DFS, and we will take one of the child and node, this node and this child, this node and this, means three combination will have three times this DFS will call, right? Three times this DFS will get called. So if three times we will move, means we are moving, means what? This node have three children, correct? This node have three children, 0, this and this we can take, right? Because these are two grandchildren, and that's why we will do what? Count of child. Count of child will do from what? We will get some value, we will get some value, we will get some value, like this. Okay, so if this is the from x we have for c1 the distance is 1, and for child c2 we have distance 1, but for the child c3 we have distance 2. What we have? We will get some value 1 plus 1 plus 2, and this sum is nothing but what we are doing here, right? So now count of node, count of this node, what we will have? 1 plus 1 plus 2 is nothing but 4 value here, right? So next time when we will do count of 4, right? Sorry, count of this node, count of this node, what we will get? We will get 4, correct? And that we are doing here, right? Count of children, we will take count of children, and we are taking answer of child. So initial value answer of child is what? We will take some value 0 or something, but next time it will come, so we will have some count for the children also, that this can be next time, this will be here it is parent, but next time it will be your children. So we will have some value, let's 4 we have here, and answer is 0. So this we will calculate, add an answer of 4, we'll add what? 4 plus 0, and then we will return something, some value, right? So this is also done, means we have to do recursively this one. Okay, you cannot recursively say in the DFS way, multiple times we will calculate and we will update our answer. Similarly, if we'll talk about this line, right? Similarly, we'll make DFS 2, right? And we'll do the same activity as we have did from here to here. Okay, so what we will do, we will update answer of child. We are doing that for answer of node, right? Here we are doing answer of node, right? But here we will do answer of child. Okay, so answer of child, how we will do that? Answer of node we have already, right? We have calculated from here answer of node, and we will have the answer of node, right? From the answer of node we will do minus count child. So initial value, this will be whatever we will have calculated 4 or something, that will come here, plus n we already have, right? N we already have, sorry, and then minus count of child, means answer of node minus count child and n minus count child, and that we will update our answer child value. Okay, so next time if we will calculate this answer child, means we already have some value, and that will be when we'll do DFS 2, it will already calculate it. Okay, so I think so this is the code we have. So I will add my live code here also after this part of the code, right? So I'll take one int answer, right? And this should be nothing but an array, correct? And this answer, and another we can take count, correct? Answer and count, we will take answer and count. Another, what we can take? We can take a list, right? List of set and another integer, correct? And a graph. Okay, and then we'll take one and we'll take in a capital. Okay, so three things we have taken here: answer, answer count, graph, and n, right? So if I'll start with a method, right? Any method, and this we can take outside the method actually here. This will be our instance variable. Okay, and this is our class. Okay, so if the n is given, if n is given and ages are given, correct, what we can do here, we'll take this dot n equal to n, correct, this dot n equal to n number of nodes, right, number of nodes is given. Now what we can do, we'll take the graph, we have ever, right, this is our graph, and then we will initialize here new array list, and we'll take like this. Okay, and this is nothing but what we have set integer. Now if we'll talk about the answer, if we will talk about the answer, right, what will happen, we have to find the way how we'll calculate the answer. We will calculate the answer using what, we have to initialize first, right, we will initialize first answer that we have calculated just now, right, and then we will increase similarly, we will initialize similarly count, and count is also nothing but new int of n, correct, this. Now we have to fill an initial value arrays dot fill, and then we will pass our count and initial value 1. I will fill all the node with initial value 1. Okay, and then I'll take a loop from int I equal to what, 0, and I should be less than n, and I plus plus, right, I plus plus, or you can say plus plus I. Okay, so if we have a graph, then what we have to do, we have to add new, I will take a hash set, okay, we will take integer of hash set like this. Okay, so we are actually adding all the uh, we are adding graph, right, and then the node on the graph, you can say. Okay, and then if that is not required, now we can take one more for loop, and this will do what, we can pass what, the loop, right, then we can pass what, loop in which we can see that int will take array of ages, int of ages from what, we will take ages from here, right, this is our given, right, this is given. Yeah, now what we have to do, we have to check on the graph, graph dot get ages, age of 0, right, and if that is there, we will add edge of 1. Correct? We'll do that here. Similarly, we'll do for what? The edge 1, and its value will be what? 0. Okay. And after that, if both are done, then we will pass DFS of 0 and then minus 1. So if we have get the edge, at the edge we have added another edge, right? And then we have added the edge value at both index, right? Now we'll take another DFS2, and this will check what? 0 to minus 1 only. Okay. And finally we will return answer. But we have to implement these two methods, right? And for that, what we have to do? We have to write here public, will take public method DFS, and then we'll take int node and another int parent. We'll take one node and another is parent, right? And then we'll take the loop for int child of graph dot get node. Got? Means we are doing here, if child we have a node we have given and another is parent we will give, right? So if we want to check, then what we have to do? We have to make a loop, and then we'll one by one we will get the child, and wait, if child is not equal to what? Parent, then we'll do here what? DFS of child comma node. Correct? And then we will do count node, then we'll take here what? Count of node is nothing but plus equal to count of child, and then answer of node is plus equal to answer of child plus count child. Correct? So what we have did? We have did DFS of child and node, then we have to do count node plus equal to count of child, and then we'll take answer node plus equal to answer child plus count child. Okay. Then we will do DFS2, right? So in the DFS2 we have to take same node from here to here, sorry, here to here definition, and we'll enter. Okay. We'll take for if child and this thing similar. Okay. Then what we'll take? We'll take answer one is different, right? This answer node we are taking, that is we have to take different. Okay. How? If child is what? If answer of child, here we will have child, answer of child is what? Equal to answer of node minus count of child plus n, and then we'll take minus count of child, and then we'll take DFS to child comma node, and this is nothing but DFS2. Correct? So DFS1 is actually calculating what we have. If we have answer of node we have, right, then we will count the children, how many children we have, what children we are getting, right, plus n minus count of child, and then we will return. Okay, so let's see the complete program what we have done till now. Right, what we have did, we have created one answer and count, then we have taken what, a graph, right, then we have taken a graph, and then we have taken n number of node, then we have taken sum of distances and int ages, then we have taken this dot n equal to n, then we have initialized all these, right. After that what we have did, we have started from here graph dot add, and then we are initializing our set, right, on the each uh, each graph, right. Actually this is nothing but a what, list, right, graph is nothing but a list, and on each list I am taking a set, right, so that for each value it will be unique value, right, and that's why I'm taking here. So what we will do, we will make a loop, and then we will at each index, right, at each index, like edges of, we will take edge of 0 is what, we will have some value, right, and that value will add here from here. Okay, edge of 1 what we have, that we will add on this edge value at that edge value. Okay, and similarly for the edge of 1 we'll do edge of 0, means we have the value. Now we'll calculate DFS1 and DFS2, and then we will return answer. Finally, the DFS is method in which we will get one by one child node, and we will take if that is not parent, then we will do DFS of child and node again, then we are finally actually calculating count and answer node, right, and count is nothing but what, count is nothing but what, count of child, right, and answer of node is what, answer of child plus count of child, and that will come to here answer of node. Then similarly we have DFS2 in which we will traverse all the node, and then we will calculate answer of child from answer of node and minus count child plus n, and we'll do minus count children, right. So actually what we are doing, we have the answer of node, right, which node we are calculating, then count children will calculate all the children, how many children of that node, that children, and then the given n we have, right, and finally we'll do minus count children, and that will store on what, count children, and finally we'll do DFS2 if that is that we have children again, right. So in this way we'll do that. Let's see, compile the code. We are getting line number 37. Oh, compatible type int n cannot be converted to int. Where integer we have, so now we will talk about count. Count is what, sorry, we have to take array. Time limit exit is coming. Okay, so we'll optimize this in another problem. Okay.